Hi everyone. In this podcast, we will see how our model allows us to analyze the impacts of shocks on the economy. Economic fluctuations are the variation of the production, or GDP, around its trend. These fluctuations are also called cycles. Shocks are the sources of these fluctuations. They disturb the functioning of the economy and push away the GDP from its trend. The economy is constantly disturbed by shocks, and these shocks have impacts on the production and on the other variables of the economy. Of course, these effects will be different according to the type of shock. Some shocks will have large impacts in the short term, which will then progressively fade away. Other shocks will have persistent impacts in the long term. In any case, fluctuations are the result of a succession of these shocks. If you remember your classes from last year, you know that there are two types of shocks: demand shocks and supply shocks. Demand shocks are caused by variations in consumption or variations in investment, for instance. They can also be caused by public policies, such as the introduction of a new tax, or when the central bank decides to implement a restrictive monetary policy to fight inflation, for example. As for supply shocks, they can be caused by changes in the production cost, such as an increase in energy prices, or an increase in productivity. In practice, the economy is often subject to several shocks at the same time. In this class, we will first study what happens when the economy is subject to one shock, and then we will consider the effect of multiple shocks. Today's lesson is dedicated specifically to autonomous demand shocks. Then, in lessons 4 and 5, we will explore shocks caused by public policies, to then cover supply shocks in lessons 8 to 10. We will first focus on short-term impacts, and then we will extend the model to medium-term and long-term impacts from lesson 6 onwards. In terms of method, we expect from you 3 levels of analysis: an analytical analysis or economic analysis, a graphical analysis, and a mathematical analysis. Let's first start with the economic analysis. First, you will have to indicate the type of shock: demand, supply, positive, negative, before indicating which markets are initially impacted by the shock and through what mechanisms. From there, you can then analyze the pressures that are triggered and how they will modify the endogenous variables, Y and R. For the graphical analysis, you can see an example here on this slide. We will learn how to analyze the impact of a shock in the plane YR, in the plane YP, as well as in the 4 quadrant graphs. Finally, for the mathematical analysis, we will learn how to calculate the multipliers for each endogenous variable. For example, we will calculate to what extent Y or R varies in the short term when there's a consumption shock. Let's focus first on the mathematical method. A multiplier describes the effect of the variation of one or more exogenous variables on an endogenous variable. This effect relies on the notions of differentials and partial derivatives. Suppose a function y, such as y equals f of x and z. If x and z vary a little bit, then we can say that the variation of y is given by the partial derivative of y with respect to x times dx, plus the partial derivative of y with respect to z times dz. This is an approximation for very small variations. dy is called the total differential of the function y. it gives the variation of y when x and z vary, again in small amounts. We can express these partial derivatives in the forms of round d's or in the form of f prime. Now, let's apply this to our model. We start from the short-term equilibrium from our equations IS and LM. We differentiate these two equations, and then we express from LM differentiated dr as a function of dy and of the other exogenous variables. We then take this expression of dr and we use it to replace dr in the first equation, IS differentiated. Then we group the terms associated to dy on one side and the terms associated to the exogenous variables on the other side. After some light adjustments, we finally get a general expression for the short-term multiplier of income, which depends on the variations of all the exogenous variables. Of course, in practice, not all the exogenous variables will vary at the same time. Usually, in our exercises, only one or two will move. For example, dg or d pi, which will simplify the expression of our multiplier. Let's try out some calculations with an example now. Suppose an economy characterized by the following behaviors. The consumption function has an autonomous component C0 and taxes that are proportional to income. The investment function depends on an autonomous component I0 and on the expected real interest rate. The demand for money depends positively on the income and negatively on the nominal interest rate. Using these functions, we can calculate IS and LM, the equations that describe the equilibrium on the goods market and on the money market. If you want, you can pause this video, calculate the equations, and express them in the form of R equals, etc. When we have the equations IS and LM, we can then easily calculate the quasi-demand YD. As a reminder, the quasi-demand, or aggregate demand, is the quantity of goods that firms can sell when the interest rate ensures the equilibrium on the bonds market. To find it, we solve the system obtained with IS and LM. One way to solve it is to express the two expressions as a function of R, and then to equalize these two expressions. We then obtain YD as a function of the exogenous variables of the model. This equation allows us to know the level of aggregate demand associated with each level of price P possible. Here, for instance, we have YD equals MS over P plus C0 plus I0 plus G plus 50 pi. Finally, we calculate the short-term multiplier. For example, here, let's suppose that there's a shock on C0 following the COVID pandemic. In the short term, firms are constrained by the effective demand. Their level of production will therefore be constrained by the demand because prices are rigid, so they cannot adjust in the short term according to our assumptions. So in the short term, the variation of the production is equal to the variation of the demand. We differentiate the equation YD with respect to the variables that are shocked, in this case with respect to C0. The partial derivative of YD with respect to C0 is equal to 1. So we obtain dy short term, which is equal to dC0. This means that a small variation of C0 triggers a variation of YD of the same amount in the short term. We can also present this result in the form of what we call a short-term multiplier, dy short-term over dc0, which is equal to 1. This means that if the autonomous consumption decreases by 1, the short-term income will decrease by 1. The multiplier is positive, which means that the exogenous variable C0 and the endogenous variable Y move in the same direction. Be careful, in our example, C0 decreases. So this means that Y decreases in the short term. Graphically, IS moves to the left, and we reach a new equilibrium E1 with lower output and lower interest rate. To finish this podcast, let's come back to the economic analysis. Let's take the same example as we did before. Households become more pessimistic. The autonomous consumption C0 decreases. Because C0 is a component of the demand, we have here a negative demand shock. This decrease in C0 increases the level of savings, irrespective of the income of households. This shock impacts two markets. First, the decrease in autonomous consumption triggers initially an excess supply or excess production on the goods market. And because savings increase, we have an excess of loanable funds on the loanable funds markets. Finally, what are the pressures triggered by the shock? On the goods market, we have an excess supply. The firms are constrained by the decrease in effective demand, so they will decrease their production to adapt to the new level of demand. Remember here, prices are fixed. They cannot be used to adjust demand and supply. We say that the equilibrium is reached by rationing the long side of the market. On the loanable funds market, the excess supply will trigger a decrease in the interest rate, which will result in an increase in private investment. However, this increase in investment will not be enough to compensate the initial decrease in consumption. In other words, despite the increase in investment, the product Y decreases in the short term. Overall, the two endogenous variables, output Y and interest rate R, decrease in the short term.